Hello, today we will learn about commutative and associative properties of addition and multiplication. These are the only two operations that have these properties, so don't get confused and remember that subtraction and divisions do not have these properties. Very well, let's begin with the commutative property of multiplication. So commutative property means that you can just like flip the values. So for example, if we have x times y is equal to y times x, and this is always true, always. It doesn't matter what values x or y have. So for instance, let's imagine that x is equal to 1/2 and y is equal to 2. Given the commutative property of the times of multiplication, we know that 1/2 times 2 is equal to 2 times 1/2. I would like to highlight the fact that here we disregard that there is any division of any kind, because actually we're not doing anything with the division. We're not including it in any of our calculations. So you could actually just look at this as 0.5 times 2. So we don't need to pay attention to the division sign since we're only manipulating on the multiplication. So having that clear, we can just make sure that this is true and that they are equal. So 1/2 times 2 is equal to 1, which is equal to 2 times 1/2. So if you have 1/2 of 2, you have 1, and if you have 2/2, you have a 1 too. So that's it, that's true, and that's the commutative property of multiplication. We have almost exactly the same thing, but now with addition. So what this means is that if you have x plus y, then this is equal to y plus x. Very well now, so if we have 2 plus 1/2, let's just put it that way, then this is equal to 1/2 plus 2. Let's just make sure. This is equal to 2.5, which is equal to 2.5. And this is equal to 2.5 as well, which is equal to 2.5. Very well, now let's go to associative property. So this means to associate, to bring together elements. So this means that if we have of multiplication x times y times z, this is equal to x times y times z. So associative property, you associate elements together. So first you associated x and y, but in the second one you associated y and z, and we must have the same values. So just to make sure that this is right, let's put some values for x, y, and z. So let's say that x is equal to 2, y is equal to 3, and z is equal to 4. So we have 2 times 3, and then all of that times 4, and we think that that is equal to 2 times as a whole 3 times 4. So we will use what we learned in the previous video, I believe, and this is substitution. So we will substitute whatever is inside the parentheses. So instead of having 2 times 3, we will substitute that with 6 times 4, and then on the right side we will use substitution again, and so we will substitute, instead of having 3 times 4, we will have 12, which is the same thing. And now we just multiply. 6 times 4 is equal to 24, and 2 times 12 is equal to 24. So this is right. And now, just very simple, very similar, we have the same property but for addition. So this means that if you have x plus y and that as a whole plus z, that is equal to x plus y plus z as a whole. And so let's put the same values for x, y, and z. So we have 2 plus 3 plus 4, and we say that that is equal to 2 plus 3 plus 4. So now we use substitution again. 2 plus 3 is equal to 5, and then plus 4, and we say that that is equal to 2, and we use substitution again. 3 plus 4 is equal to 7. So 5 plus 4 is equal to 9, and 2 plus 7 is equal to 9 as well. So this is right.